Once the data arrives at the destination computer, it travels up the stack with each layer examining and removing the headers and trailers added by the corresponding layer on the source computer. The physical layer sends the bits up to the data link layer, where they are reassembled into a frame. The data link layer verifies the checksum and removes the layer 2 frame. It then sends the packet up to the network layer. The network layer examines the layer 3 destination address and verifies that the packet arrived at the correct destination. Next, it examines the protocol number to determine the transport layer protocol. It strips off the layer 3 header and sends the data up to the appropriate transport layer protocol. If the transport layer is using TCP, it collects all the segments, reassembles the data, and sends an acknowledgement to the sending computer indicating that the data was received. If the sending computer does not receive the acknowledgement, it resends the segments. Next, the transport layer examines the port number and sends the data to the correct application layer protocol. The application layer protocol handles the data in whatever manner is specified by that specific protocol so that it can be used as intended on the receiving computer. In this section, we took an in-depth look at what happens at each layer of the reference model we referred to in most of this course. To learn more about the protocols used at each layer of this model, click the first link on screen. If you're interested in seeing how this same general networking functionality is associated with the 7-layer OSI reference model, click the second link on screen. You have reached the end of this section. Click Next when you're ready to continue. Click the links in the table on the screen to learn more about protocols used at each layer of the 5-layer reference model. When you are finished, click the link on screen to return to the main topic. The Domain Name System, or DNS, associates various information with domain names. Most importantly, it serves as the phone book for the Internet by translating human-readable computer host names, such as www.example.com, into IP addresses, such as 208.77.188.166. Networking equipment needs to know these IP addresses to deliver information. File Transfer Protocol, or FTP, is a network protocol used to transfer data from one computer to another through a network, such as over the Internet. The Simple Mail Transfer Protocol, or SMTP, is the most popular protocol for sending electronic mail on the Internet. The Hypertext Transfer Protocol, or HTTP, is a communications protocol for the transfer of information on the Internet and the World Wide Web. User Datagram Protocol, or UDP, is a very simple and fast protocol for sending data. UDP is a best effort delivery service providing no delivery notification, error checking, or recovery procedures. Transmission Control Protocol, or TCP, is a protocol for sending data that provides delivery notification, error checking, and recovery procedures. With TCP, the receiving computer tells the sending computer when the data was received. The Internet Protocol, or IP, is the protocol used to send data from one computer to another on the Internet. Each computer or host has at least one IP address that uniquely identifies it from all other computers on the Internet. Ethernet is a LAN network technology developed in the 1970s. Its set of standards define rules about frame format, as well as how computers communicate with each other over a single wire shared by all devices on the network. The Open Systems Interconnection, or OSI reference model, is a layered, abstract description for communications and computer network protocol design. Isolating specific operations to a specific layer simplifies the job for software developers because they can concentrate on the functions specified for a particular layer. Let's examine the functions specified for each layer. Click each layer to hear the details for that layer. When you are finished, click the link on screen to return to the main topic. Layer 7 is the application layer. The application layer specifies network-related functions for a user application or program. It's important to note that this is not the user interface itself, as the OSI model does not specify any end-user functions. When a user chooses to read an email, transfer a file, or surf the network, the user software program, such as a web browser, interacts with the application layer. Layer 6 is the presentation layer. The presentation layer accepts the data from the application layer, and converts or encodes it into a standard format that the application layer on the other computer can understand. For example, text can be encoded as ASCII or HTML, while graphics can be encoded using standard formats like JPEG or TIFF. The presentation layer can also involve standard data compression or data encryption schemes, ensuring that the receiving computer can properly uncompress or decipher the data. Layer 5 is the session layer. The session layer establishes, manages, and ends the connections or sessions between the applications on the communicating computers. For example, a web conferencing application has to maintain separate sessions for each user participating in the conference. The server runs one conference application but tracks each session individually. Layer 4 is the transport layer. The transport layer takes data from the upper layers, converts it to a format that can be transmitted over the network, and manages the flow of data between the two hosts that are communicating. The OSI reference model identifies two different types of service at the transport layer: connection-oriented transport service and connectionless transport service. The connectionless transport service is a best effort delivery service. This connectionless service provides no delivery notification system, error checking, or recovery procedures. The sending computer does not know if the destination computer received the data. The connection-oriented service is responsible for making sure that the data is delivered error-free and in the proper sequence. Flow control can also occur in this type of service. The connection-oriented service can dynamically adjust the flow of data from one computer to another so that the transmitting computer does not send more data than the receiving computer can handle, especially when there might be a difference in connection speeds. Layer 3 is the network layer. The network layer takes the segment from layer 4 and adds a header to it to create a packet. The network layer is responsible for delivering the packet to the destination computer. If there is more than one route to the destination computer, the network layer chooses the best path for the packet to take. The network layer treats each packet independently, so it is possible that two packets from the same transmission might take different paths to arrive at the destination computer. Layer 2 is the data link layer. The data link layer takes packets from the network layer and adds another header to form a frame. The data link layer can also add a trailer to the frame, such as a cyclic redundancy check or CRC. A CRC is a simple mathematical calculation performed on each frame to ensure it hasn't been corrupted in transit. Finally, the data link layer translates the frame into binary digits or bits for the physical layer. Layer 1 is the physical layer. Layer 1 is where binary digits, or bits, move across a physical medium. Layer 1 defines the electrical or optical signal that equals a 1 and the signal that equals a 0. Physical layer standards, including cabling specifications, electrical or optical signaling, and lower-level framing of 1s and 0s.